Metal joining processes. When a product is not made as a single piece, it has to be made into number of pieces and joined to get the final shape of the product. Also, in order to join end to end or to join different pieces together, in all such cases, we use metal joining processes such as welding, soldering or brazing. Welding. Welding is a process of joining two parts by heating the portions to be joined which fuse together to form a joint. Filler metal, electrode, may or may not be used to make the joints. Welding processes are classified as follows. Figure 1. Classification of welding processes. Welding process is broadly classified into two types. 1. Fusion, non-pressure, welding. 2. Plastic, pressure, welding. Fusion welding is further classified into A. Gas welding, oxyacetylene or oxyhydrogen, B. Arc welding, metal or carbon electrode, and C. Thermite welding. Pressure, resistance, welding is classified as A. Spot welding, B. Seam welding, C. Projection welding and D. Butt welding. 1a. Gas welding. Figure 2. Gas welding. This process consists of a torch which is connected to two cylinders, oxygen and acetylene, by means of hose pipes. The cylinders have pressure regulators to adjust the flow of oxygen and acetylene gas. The length and intensity of flame is controlled by means of two valves in the torch handle. A filler rod is used to form weld bead along the joint. The filler rod melts in the flame of torch and forms a molten metal bead to join the parts together. The gas welding process is clean, noiseless and cheaper process. The weld quality will be good and joint will be as strong as the parent metal. The equipment and welding process is shown in the figure 2. 1b. Arc welding. The arc welding equipment consists of a welding generator or transformer, an electrode holder, cable connecting power source to electrode holder and earthing cable or rod. The work pieces to be joined are cleaned and the surfaces are prepared. The workpiece is connected to the positive terminal or earthing rod and the electrode holder is connected to the negative terminal or vice versa. When the electrode is brought very near to the workpiece, without touching it, a spark will jump between the terminals. This will generate high heat to melt the electrode, filler rod. If we use metal filler, then it may be either coated with magnesium or sometimes non-coated electrode may also be used. If we use carbon electrode, it will not melt but the heat of the arc will make the parent metals to melt and form the weld bead. During the welding process, the temperature at the center of the arc will be around 6000 degrees centigrade, hence the metal easily melts and flows at the joint. The rate of fusion can be controlled by selecting suitable voltage or current in the welding transformer. The weld bead is protected from oxidation by the gases evolved during the burning of coating material around the electrode. Arc welding is suitable for most of the steels and their alloys. It is a versatile welding process used to make strong joints. The schematic diagram shows the arc welding setup and the welding process. Industrial applications of arc welding. High-quality welds can be made in fabrication of tanks, boilers, pressure vessels, structural works, bridges and buildings. Figure 3. Arc welding process. 1c. Thermite welding. In this process, the two parts to be welded together are kept in position with a uniform gap between them and a mold is made around it. The passage to fill thermite, which is a molten metal mixture consisting of aluminium powder and iron oxide in the ratio 1:3. Thermite is poured into the mold which will occupy the cavity between the parts to be joined and raises through the riser. Once the thermite solidifies, the mold is collapsed, riser and other projections are removed. Then the joint is finished by grinding. Figure 4. Thermite welding. 2a. Spot welding. The principle of resistance welding is that when current passes through a conductor, it offers resistance to the current flow. Due to this resistance, heat is produced. This head is used to join the metal parts. In spot welding, the parts to be welded in a particular spot, point, are kept in position between two copper electrodes. The workpieces to be welded must have uniform surface and intimate contact after applying pressure between two arms, fixed and movable arms which carry copper electrodes. Once the arms are pressed against each other, due to resistance of workpiece for the current flow, heating takes place at the surface of contact. This local heating at a particular spot between the two pieces helps to join the two parts. 2b. Seam welding. It is similar to spot welding. The only difference is that the seam welding process is continuous spot welding. The workpieces are placed between two rollers, one of which is fixed and the other is adjustable to hold two workpieces together in between the rollers. As the rollers roll slowly, and current flows across the rollers, a series of spot welds are done. This resembles stitching operation. Seam welding is very effective in producing continuous and leak-proof joints in tanks, barrels, pressure vessels and mufflers. 2c. Projection welding. This is also similar to spot welding, but one of the plates is corrugated, have projections, while the other is flat. The plate having projections is welded to flat plate or sheet by fixing the plates between dies which act as electrodes. As current passes across the dies, the plates are welded at projections. Since it involves pressing operation, welding is quick. It is suitable for sheet metals, cast, forged mechanical parts. Figure 5. Spot welding. Figure 6. Seam welding and projection welding. 2d. Butt welding. In this process, the two workpieces are fixed in copper jaws and kept close to each other in contact. As the current flows, due to resistance at the contact surface, high heat is generated and hence the two parts fuse together. It is done in two ways. 1. Upset butt welding. In this process, the two parts to be welded have no gap between them. When current passes through the jaws and workpieces, pressure is applied, hence two pieces get red hot and fuse together. No melting of workpieces nor filler material is needed. Bars, pipe ends can be joined together by upset butt welding. 2. Flash butt welding. In this process, the surfaces of two workpieces which face each other must be uniform and a very light contact is maintained between them. When high current passes across this small gap, an electric arc or flash is established, as a result of which both the parts are heated to a temperature of fusion and joined together. Types of welding joints. The most common welding joints are: A. Lap joint, used to join overlapping sheets or plates. B. Butt joint, used to join ends of plates in the same plane. C. T-joint, used to join plates perpendicular to each other. D. Corner joint, used to join plates at perpendicular edges. E. Flange joint, used to join bent edges to form a flange. The welded joints commonly used in industry are shown in the adjacent figure. Figure 7. Upset butt welding and flash butt welding. Figure 8. Types of welding joints. Soldering. Soldering is the process of joining two parts or pieces of metal by adding a fusible metal or alloy called solder. This operation does not involve heating or melting of parts to be joined. It uses solder, which is an alloy of tin and lead which melts at low temperature in the range 150 to 250 degrees centigrade. Solder will not stick to dirty or rusted metal surface. Hence, the surfaces of the joining parts should be cleaned using emery paper or brush. Zinc chloride is used as a flux in this process to prevent oxidation of the surfaces to be soldered. Applications: to connect components in electrical and electronic circuits, devices and appliances. Types of soldering. A. Soft soldering. This uses tin and lead alloy. B. Hard soldering. This uses copper and zinc which melt above 900 degrees centigrade temperature. Brazing. Brazing is the process of joining two similar or dissimilar metal parts by using a fusible alloy called spelter, which is a copper and zinc alloy. Brazing uses a torch and filler rod, similar to gas welding process. It is carried out at temperatures above 600 degrees centigrade. The brazing operation may be classified as A. Torch brazing, B. Dip brazing, in which the parts to be joined are held together and dipped in the molten spelter, and C. Furnace brazing. The strength of brazing joint is relatively high compared to soldering. Metals such as copper, brass, bronze, steel and stainless steels can be brazed. Figure 9 Soldering process. Figure 10 Brazing process.